Today we're covering properties of similar polygons. This is 8th grade, Chapter 2, Lesson 1. Our first word is similar, and similar means same shape, different size. Same shape, but different size. Kind of like the example they give you down here. Same shape, different size. Congruent means same shape and same size, basically equal. Same shape and same size. Corresponding means in the same position or the same place. You might say they're matching, like side AB matches with side PQ. They're in the same place. This right here is red triangle ABC is similar to triangle PQR. So this little wavy sign means similar. And we might say angle A is congruent, and congruent is a wavy equal sign. So congruent to angle P. And I know because they're in the same position, they also mark it with one line. Notice one line there. And then angle B is congruent to angle Q because they're in the same position, and again they're marked with two little lines. And then we have angle C, which is congruent to angle R, and it's marked with three lines. Then let's talk about not just the angles, but the sides are also corresponding. Side AB corresponds to side PQ. So we might write that like this as a proportion. AB is to PQ as AC is to PR. The big triangle I listed on top in both places, and the matching sides I listed for the little triangle on the bottom of the proportion. This is a test type question. So corresponding angles are congruent, which means they're equal. If they're in the same place, they are equal. Corresponding sides are proportional. They're not the same measurement, but they are proportional. And if you remember a proportion, we can solve for because they are two equal fractions. A dilation is a transformation that makes a shape either bigger or smaller. Scale factor is the ratio of any two corresponding sides in two similar shapes. Scale factor is the ratio of any two corresponding sides in two similar shapes. You can use the scale factor of similar figures to determine the missing measures. So, for example, we have two triangles. There is triangle A, B, C, which is the big triangle, and then it is similar to triangle D, B, E. And notice when they list this, they're in very specific order. A corresponds to D, and B corresponds to the other B, and C corresponds to E. So if you're matching up the angles, you can just use the letters in the order they listed them. Let's start by setting up a proportion, because after all, a proportion is a ratio. A ratio is a fraction. So we have side DB, and I'm using that because I can see the measure. It's 8. So DB corresponds to side AB. And again, you can use the letters as they give them. So they gave us DB, first two letters, and I know that's going to go with AB, the first two letters in the other one. And this time I want to match them to their measurements. So DB was 8, and AB is 16 plus 8. And 16 plus 8 would make 24. Now if I simplify that fraction, I'll have the scale factor. So 8 and 24 can both be divided by 8. So that would simplify to 1/3. The scale factor for this is 1/3. If I want to find a missing measure on the small triangle, I need to multiply by 1/3. So let's use that scale factor to determine the missing measurement. There's my X right there. I want to figure out what the X is equal to, so I need to find the corresponding side. DE corresponds to AC. AC corresponds to DE. So X is going to equal 18 times 1/3. And to multiply times a fraction, I need to put that over 1. And I can simplify, and I get 6/1, or just 6. So that missing measurement is 6. And anytime a scale factor for a reduction, anytime the scale factor is less than 1, it's a reduction. It's making it smaller. If the scale factor is greater than 1, it's an enlargement. Like if you took a picture and to have it blown up, you want a poster of it, then it would be like, I want it to a scale factor of 15. I want you to multiply the current size times 15. Or maybe you take a picture in to be reduced because you need it for an ID. You might say you need it to a scale factor of 1/5 because you want them to shrink it. Let's look at the examples you're supposed to do today on the independent practice. It says each pair of polygons is similar. We're going to determine each missing side. So you're just solving for the X. We need to figure out what it corresponds to on the known shape. And you can use the angle markings to figure out which sides correspond to what. So this side here corresponds to this one, or 4 corresponds to 10. So this came from the small shape, and this number down here came from the big shape. So I need to pick another number for the small shape that will correspond to that X on the big shape. Well, that would probably be the 5.6. And then I solve the proportion. And you might try simplifying and then cross multiply and divide to solve proportions. The second one, I'm going to help you set it up. I'm not going to solve it, but I will help you set it up. You need to look at the little bitty tiny markings to see which angles correspond to which sides. So this one is turned around. A trick that I use is I take all the numbers from like the small shape and I put them into the big shape. For example, this has 4 lines in this corner here. So that would be this angle. And this one has 3 lines, so that would be this angle. So the X goes with that 18. And I'm going to do the same thing for the rest of it. This has 1, and it's between the 1 and the 4, so that matches with the 12. 6 matches with 12. And then this is 2, and this is 3, so that goes here. And the only one left is 3. So these are the different fractions I could use in my proportion. I definitely have to use the one with the X. So X over 18. And remember, the numbers inside are my small shape and the numbers outside are the big shape. So when I write the next fraction, I got to remember to put the small number or the number on the inside on top. I'm going to use a small number, the 3 and the 6. And it doesn't matter which one you use, as long as you make sure that the numbers on the inside go on top and the numbers on the outside go on bottom. And then you solve the proportion. And that one's a pretty easy one to solve. Let's practice lining those up again. So I'm going to take the numbers from the little one and I'm going to put them on the inside of the big shape. That looks like it will go here. And the 4.5 goes with the 6. So that didn't give me as many options. These are the fractions I have to use. So little shape on top, big shape on bottom. Little shape on top, big shape on bottom. One more. Okay, so this is between the 1 and the 2. So the 1 and the 2, that means 3.5 goes here. The X is between the 1 and the 3. So that means X goes with 8. And the only one left is 5. So these are the different fractions that I will have to use. Again, I just picked one. It doesn't matter. You can pick the other one. Little on top, big shape on bottom, and again, little shape on top, big shape on bottom, and then solve the proportion. The last question says, a blue rectangular tile and a red rectangular tile are similar. The blue tile has a length of 10 and a perimeter of 30. The red tile has a length of 6. What is the perimeter of the red tile? So not only with sides, but we could also use it to set up perimeter. So I'm going to draw, it said blue, so I'll use blue. The length is 10 and the perimeter is 30. On the red tile, it said the length is 6 and we don't know the perimeter. So I'm going to set up a proportion. The number I know, the little one, 6, the big one, 10. Big, we'll say red and blue. So the perimeter for the blue was 30, and I don't know what it is for the red. So I set up a proportion, but instead of using the sides, I used the perimeter, and you're still just solving the proportion.